Okay, welcome to the day 4 video. Today we're going to talk about linear system application word problems. So we're going to talk about how to solve and set up the word problem systems. To do that, you need to read the problem carefully, determining the totals. If there's only one total, it is not a system. You only have one variable in the equation. But if there are two totals, then it is a system, and you must have at least two variables in the equation. And I always say, two totals, two variables, two equations. Determine what the totals represent to help you create the equation. So example, if we're talking about the total of 30 coins, the equation should add the coins. But if it's talking about total of $40.80 from the coins, then the equation must have the money value included by the variables. And then after the equations are set up, you can determine the correct method to solve, either using elimination or substitution. Either one is fine for these. They're both algebraic. You can choose which one, but some may lead themselves better for elimination or substitution. Okay, so let's look at the first one together. At a quick lunch counter, 6 pretzels and 2 cups of soda cost $5.50. 2 pretzels and 1 cup of soda costs $2. Find the cost of the pretzel and the cost of a cup of soda. So here we have our two totals, and I'm just going to put a box around them so you know. This $5.50 is a total, and the $2 is a total. So this tells me I have two totals. I'm going to have two equations and two variables. So I'm going to start by writing out my let statements. So again, I had two totals, so I knew I was going to have two variables and two equations. X was going to be the cost of a pretzel, and Y is the cost of a soda. Remember that we can figure that out by looking at our question. They're asking us to find the cost of a pretzel and the cost of a cup of soda. Those are the things that I don't know. Okay, so now I can set up my two equations. The first one comes from the 6 pretzels and 2 cups of soda costing $5.50. Well, to find out the total that I spend, I need to multiply the 6 pretzels times their cost plus the 2 cups of soda times their cost to equal the total. So it'll be 6x, 6 pretzels, plus 2y, 2 cups of soda, to equal $5.50. The next one then is 2 pretzels, so 2x, 1 soda, so 1y, to equal $2. Okay, now I think this one is set up best for elimination since I have x, y, and then the constant on the other side, so it's set up in that ax plus by equals c form. So to make them have the same number in front with opposite signs, I'm going to multiply the bottom one all by a -2 because I have the 1y in front. So nothing is changing with the 6x plus 2y equals 5.50. And the bottom one is becoming -4x minus 2y to equal -$4. -4. Now these are ready to combine and make them into one equation. So the 2y minus 2y cancels. 6x minus 4x is going to be 2x equals 550 minus 4 is $1.50. And then I divide both sides by 2. And that'll give me my x equals 0.75, so 75 cents. So when I go over to my let statements, I can write that next to the x. And now that I know what the x is, I'm going to come over to the left side just because that's where I have some space to sub in to one of the equations to solve for the y. I think it's going to be easiest to do the 2x plus 1y, or just plain old y equals $2, because that's going to be easier to solve. So then I have 2 times the 0.75 plus y equals $2. 2 times 0.75 is 1.50, 1 5/10 or 50/100ths, plus y equals 2. And then I can subtract the 1.50 from both sides, or 1 and 50/100ths, to be y equals 50/100ths. So in my let statement now I can write that the cost of a soda is 50 cents. Now, I don't have to write out the check, but it's always a good idea to at least go to your calculator and plug in the 6 and then parentheses, subbing in your x value, the 0.75, plus 2 parentheses, the 0.50, 50/100ths to put in y, to see if it equals 550, and then the same thing for the 2x plus 1y equals 2. So we're checking still, I'm just not writing it all out. Okay, on to the next question. Okay, the next question says that Max and his father Kirk are comparing their ages. They know that the sum of their ages is 52, and that Kirk is 7 years older than 4 times Max's age. Determine the age of Max and his father. So here, all I have is the one total, that their sum of their ages is 52. So that tells me I'm going to only have one equation, and that means that I'm only going to have one variable. So this is using one of those comparisons. So I know that the sum of their ages is 52, so they're going to total 52. Kirk is 7 years older than 4 times Max's age. Who do I know nothing about? I know nothing about Max's age. So my x is going to be Max's age, and then Kirk is 7 years older than 4 times Max. So that means 4 times Max, so 4x, and 7 years older than that is the plus 7. I always put that in the beginning, after the 4x, I start with the 4 times Max, even though it came second, because it's 7 years older than. Remember when we use older than, more than, less than, it comes after, and it's very important when we have less than, because that would be subtracting, make a big difference in your answer. So then the 4x plus 7 is Kirk's age. So now I have my two statements, and the sum of their ages is 52, so I can add the two amounts up, x and 4x plus 7. So adding the two ages, x plus 4x plus 7, to equal to 52. Combine my like terms, the 4x and the x gives me 5x plus 7 equals 52. Then constants on the right, so I'm going to subtract the 7 over since the variables are already on the left. 5x equals, and then 52 minus 7 is 45. Divided by 5 tells me that x equals 9. So up to my let statement, I can put x, Max's age, equals 9. And then for Kirk's age, we're going to go to our calculator, and we're going to put that in. 4 parentheses when we sub in, 4 times 9 plus the 7, which would then equal 43. So their ages are 9 and 43. And that's my answer for this one. So again, I knew that I was only going to have one equation, one variable, because of the 52. So that's how I knew to only use an x for this problem. Okay, the next question says that a purse contains $7.60 in both quarters and dimes. In all, there are 40 coins. And then the question says, how many of each kind are there? Well, I had already boxed in two totals here, $7.60 and 40 coins. So again, that is my clue that this is going to be a system. So I'm going to have two variables, let x equal the number of quarters, because there's two amounts I don't know, the number of quarters and the number of dimes. Now the reason I put the number of is so that I know what I don't know is the number, not necessarily a value. So, and then the y is the number of dimes. And now I can go ahead and set up my equation. So I know that I have $7.60. Well, in order to add up to money, I have to have the money value here. So actually in front of my let statements, in front of the let x equal the number of quarters, I'm going to put in the 0.25 or 0.25 if you prefer in parentheses in front. So I remember that a quarter is worth 25 cents, and a dime in front of that, I'm going to put the 0.10 to show that that's 10 cents. Now I'm ready to set up my equations with the $7.60 by multiplying the value times the x. So that'll be 0.25x, and you can use parentheses around the x if you want to. I usually do because it's very important when we have a binomial or a trinomial. So 0.25 times the number of quarters, and then 0.10, the value of a dime, times the y to equal $7.60. Now that's just going to be equivalent, so maybe you didn't need to write that, and maybe you just realized that that's 0.25x plus 0.10y to equal $7.60. And then the next total is the number of coins, x. The total number of coins is just the number of quarters plus the number of dimes, so x plus y to equal the 40. All right. Now there's many different ways to solve this one. You could do substitution since the x and the y are by themselves without a coefficient in front, so I could just move one over to the other side. But we can also eliminate, because it's x y number, or constant, and then xy in the constant. I'm going to multiply the bottom one by negative 0.10. But again, you could use many different things. We could eliminate x, we could use substitution, many different ways to solve this one. So then in the next step, I have 0.25x plus 0.10y, because nothing changed in that top equation, to equal the $7.60. And then in the bottom, I'll now have negative 10 hundredths x minus 10 hundredths y equals, and then we can do 40 times negative 0.10 to equal the negative 4. And then we can combine these. The y's will cancel. 0.25 minus 10, 25 cents minus 10 cents is 15 cents. X equals $7.60 minus $4 is $3.60. And then we can divide both sides by the 15 hundredths. Put that in your calculator, and that'll give you an x value of 24. Now that I have my x, I can use one of the equations to solve for y. I think the easier one is the x plus y equals 40. Much easier than dealing with the decimals. And then I have the 24 plus y equals 40. And then to get y by itself, I'm going to subtract 24 from both sides, 40 minus 24 then. So my y value is 16. So now I can put both of those into my answers. I do that by going back to the let statement and putting in the number of quarters is 24 and the number of dimes is 16. Remember that you can then check it in your calculator to make sure that it checks in both equations. So the 24 plus 16 to equal 40, and then the 0.25 times the 24 plus 0.10 times 16 to make sure that it equals $7.60 by plugging into both of the original equations. Okay, on to the next one. Okay, the next question says Lily and Rosie are sisters. The sum of their ages is 19, and the positive difference of their ages is 9. Set up a system of equations involving Lily's age L and Rosie's age R, assuming that Lily is older, and then solve. So they already gave me my let statements. They told me them in the statement, but I'm still going to write them out in the question, but I'm still going to write them out. And then when I look in here, I'm going to box in. So I wrote down let L equal Lily's age, let R equal Rosie's age. That was from the statement itself. I knew that the sum of their ages is 19. And I also know the positive difference is 9. So that tells me that I have two totals here. That's how I would also know I'm going to use two variables, but they told me the two variables in the equation as well. Okay, so now I can set up the equations. The first one, the sum of their ages, that just means add their two ages. So Lily is L and Rosie is R, so the L plus the R will equal 19. And then the positive difference, well, in order for the difference to be positive, we have to take the older minus the younger, and they told me that Lily was older, so that tells me I need to do Lily minus Rosie to equal the 9. If I switch those around, I would have a negative number since Rosie is younger. Okay, so now this is actually already set up for elimination because it's R minus an R, so these R's will cancel. So then I'll have L plus L, which is 2 L's, equals 19 plus 9 is 28. And then I can divide by the 2 to tell me that Lily is 14. So I'm going to jump over and put that into my let statement. Lily's age equals 14. You could do that at the end or during, whichever one's easier for you. Now that I know what L is, I can use that to find R. I think it's easier to do that with the top equation since it's addition, so L plus R equals 19, but really either one would be fine. And then I have L I know is 14 plus R equals 19. And then I would subtract the 14 from both sides. 19 minus 14 would mean that Rosie is 5. So now I can put that in my let statement. So now I have my answer, Lily is 14 and Rosie is 5. We can check that by putting in the L and the R in the equation. 14 plus 5 equals 19. 14 minus 5 does equal 9. So I'm confident with my answers. Okay, last one. Irene has $4.50 in her coin bank in nickels and dimes. The number of dimes is twice the number of nickels. How many of each type does Irene have? Well, we know that there's only one total here. I know that her total amount of money is $4.50. So that tells me I'm going to have one variable and one equation here. So my let statements are going to be, starting with let x equal, what do we know nothing about? Dimes is twice the number of nickels, but we know nothing about the number of nickels. So my x is the number of nickels. If that's my x, then I know that my number of dimes is twice the number of nickels, so that would mean 2x is the number of dimes. And now that I have this, I'm also going to put in front the amount of money. Since the total is an amount of money, I need to make sure that it's money plus money, not number of nickels and number of dimes. So in front of the dimes, I'm going to put the 0.10, and in front of the nickels, I'm going to put the 0.05. Don't put 0.5, it's 0.05, not 50 cents, 5 cents. Then once I have those, I'm ready to set up my equation, starting with 5 cents times the number of nickels plus 10 cents times the number of dimes to equal my total amount of money. Now, since I only have one variable, this is just a solving as usual. 0.05 times x, 0.05x. 2 dimes is 20 cents, so 20 hundredths, or 0.20x equals 4.50. 20 cents plus 5 cents is 25 cents. 0.25x equals 4.50. And then to solve for x, we're going to divide both sides by the 0.25 or 25 cents to then end up with x equals 18, which is good because if it was a decimal, that wouldn't be a good answer since it's talking about a number of nickels. So next to the number of nickels, I'm going to write that. And now that I know what my x is, the number of dimes is twice that, so 2 times the 18 to equal 36 for the number of dimes. And then remember, you can plug this in and check in the calculator. Okay, so that's it. We'll go over this more in class. Have a great day.